Okay, so I was reading through some old notebook that I had, and I found a note that I made to myself to try and explain what an object actually is when we're talking about programming. And this way, thinking about objects, I feel like has really helped me with programming. And I thought that I would just rewrite it here and then just read through this note that I made to myself in hopes that maybe somebody else hears this. And it also helps their understanding of objects in programming. And I made this note to myself because I didn't fully understand the concept because when I first started learning programming, I was just watching random YouTube videos as my main source of learning rather than reading through books, which I found so much better these days than actually just the random videos you get on YouTube. And my definition of what an object is and how I kind of think about them these days, I believe originally came through the C++ Programming and Principles book. I think that was its name, written by the original creator of the C++ programming language. And obviously these days I'm learning Odin, but this note was written to myself when I had to learn C++. And essentially, it is the C++ standard defines object as a region of data storage in the executable environment that contents of which can represent values. There's also another reference here that kind of backs up what I'm saying. An object represents a region of storage, typically RAM or a CPU register, that can hold a value. Objects also have associated properties that later goes on. But essentially, this is the main way that I think about objects and how I feel has helped me in my programming. So I'm just going to read through this note now, and hopefully somebody learns something or has a new way of thinking about objects if they're like me and they started learning programming only from object-oriented programming languages where the word object can get a bit confusing if that's your first time ever being exposed to it. So, what is an object? An object, on a technical level, is a region of computer memory that can be read from and have its data written to. In a higher level sense, an object is something in our source code that has a data type, a name, ideally a human readable name. There are some beautiful examples out there where you get somebody else's code and there's just a variable like BP, something like that, and it has no reference, no comments, no nothing, and you just kind of have to guess what it is, and that's it. And possibly initialized computer memory. So when you create something, depending on the programming language, the memory that is associated with that object that you have created could either have garbage memory there, or if you're using a programming language like Odin that has zero initialization, everything is forced to have some value already stored inside of there. Because in almost every circumstance, you'd rather have an expected value there rather than some garbage memory, as that can cause hard to debug errors later on in larger projects, even simpler ones. The data type of an object is what dictates its size, how many bytes of data will be taken up. The type defines what the data in an object actually represents. So objects in computer memory are essentially just bytes. They're just ones and zeros, but these ones and zeros have different meanings depending on the type of the object. So in this case, chars, very, very common throughout all the programming languages. In Odin, that's the one I focus on more. Chars are called runes instead, but they're essentially more or less the same thing. There is some nuances to them, but they are a byte and are used primarily to represent single symbols. So more or less any symbol that you can find on your keyboard. There's a few hidden symbols there, but if you just look up the ASCII table, that's essentially what a value in a character is going to represent. There are cases in C++ where, because a character is just a byte, you can use them just to represent some type of range between 0 to 255. Then we also have booleans. Now, booleans are also a byte, and they are used for true and false values. So here's an example of two objects that are the same size or will be the same size if they're created with these data types, but the data is going to be represented differently. The ones and zeros in a character is going to represent probably some symbol on my keyboard, and the one or many zeros, there's probably only one bit that gets flipped inside of a bool, is simply going to represent a true or false value, even though they are the same size internally. They'll take up the same amount of data. Finally, the type dictates what operations can be applied to it. Numbers like ints can be multiplied to each other, whereas bools often can't be. And there might be some examples of programming languages out there because a bool under the hood is just a 1 or a 0. Where you go, well, in this language, I can multiply bools together. But a good example of that is I have a little example here. In Odin, I have two booleans, x and a y, and I'm simply trying to multiply them down here. So if I back out of this, and then I just do an Odin run dot, you will see we'll get an error. Because the operator, the star, the multiply symbol, is only allowed with numerical expressions. I could go back inside of this right now, and then I could go, well, this isn't going to be a boolean. It is going to be an int, and a false is a 0, not a null, a 0, and a true is a 1, and I'll make you an int over here. So the only thing we've changed of these objects is the data type associated with them. Their names are the same, and the value stored within them is the same, and the operation I am trying to apply to them is the same. Only thing that's changed is the data type, and now you can see we get a 0 printed out because 1 times 0 is 0. Where are we? Multiply to each other. Where cannot be. So the name in that example we had x and y, which is a terrible name outside of an example or in some very niche use cases. Usually speaking, you want to have actual descriptive names for your objects because it just makes working with them so much easier. I have now, since programming and stuff, come into cases where I've gone back to old code and I've just looked at it and go, what the fuck was I thinking? What does this mean? Ask Jack, you're an idiot. So names, they're good. Name your shit. The name is simply there for the human programmer. The machine itself does not care as long as it follows the compiler/interpreter rules. So compiler/interpreter, if you're new to programming, there are essentially two ways we can have programs run on our computers. A compiler is a program that will take our source code, those are the text files that we have written as programmers, and it will translate those text files into an executable file. You'll have seen that just then with the Odin example, as Odin is a compiler that takes in a source code file, which I wrote in that example. It takes that little Boolean example and it turned it into an executable file, and the run command passed into the Odin compiler then ran that executable. Whereas we have interpreters. So Python is not, it is a programming language, but it's not actually a programming language when you think about it. Python is a program known as an interpreter. A Python interpreter will take a file that ends in the .py extension, and then it will read through that file, and it will translate line by line all of that stuff into source code, but it will do it at actual runtime. It will not create a executable. It will just read the file in. And that is a very kind of bad explanation of what a compiler and an interpreter is. So even then, that's not the computer, but those programmings given the errors here. This is just me saying that when an error for a name of an object throws up, the computer itself doesn't actually care what we've named these things, but the compilers and interpreters, they have actual strict rules on what we can and can't name objects inside of our source code files. Most of them, they don't want you to store your objects with names with a number or maybe a dash. They don't want certain symbols inside of them for particular reasons. And if you break one of these rules, you will get some type of compilation error, or the interpreter will go, I don't know what to do, so I'm going to crash now. In the background, the computer just uses the raw memory addresses. So where does this object live inside of RAM? There is a data structure which, at the time, I thought it was called a lookup table, but I believe now it is actually called a symbol table is the technical name for it. Don't 100% quote me on this one. I still need to look more into that side of what it actually is. But this data structure, whether it is the lookup table or it's called the symbol table, that keeps track of certain things like objects location with some other information such as their data type. Then there is memory. This is simply the bit values that are currently being stored within the region of memory that object lives in. So we go to the memory address of that object. The data type defines how much space from that memory address gets occupied by that object. Its value, its memory will be written there or read from there. And the type of the object will have a big dictation on what values can actually be placed here. So if you have an object that is a Boolean, for example, chances are there might only be zeros or a 1 there, and that is it. If we have floating point numbers and integers, we could have them store the same value, like 32, but if you look at the actual bit pattern of them, because of the way floating point numbers are actually, interpreted, how they work behind the scenes, the bit values for the byte, for the integer and the float will be very different from each other. So the data type has a big impact on what the memory actually looks like inside of the region that the object lives in. A common misconception we had, so by we I'm meaning me, this is my own personal experience, but I'm probably not the only person. Often in my notes I say we For some reason, I refer to like my past and future self in my notes. But is that they only apply to object-oriented programming. I'm assuming this probably comes up with other people who learn programming, especially when their first exposure to programming is from an object-oriented programming language. And you kind of, or at least I developed the belief that an object is only something that refers to a class inside of object-oriented programming. But this new way of thinking about objects, that essentially anything that has a region of computer memory associated with it that we can read and write values from is an object, I have found to be a much better way of thinking about them, and to just think of classes as extensions of objects instead. This, however, is not the case. As stated above, an object is simply a region of computer memory that has some data inside of it. This means that even the built-in types that all languages come with, such as bools, ints, chars, are all objects. They are very simple objects and are often too limited on their own to represent complex data models, but they are objects nonetheless, as they follow all of the things we defined above. So they all have a data type associated with. If any objects that are created from there, then any objects of these will have a name and they will have some type of value. That's how I interpret what an object actually is. And the reason we have object-oriented programming is that there was a need or a want. I wasn't there when C++ was made. I'm not sure if they really just needed this style of programming or they just really wanted this type of programming. For the ability to combine the data that would have often lived in structs. So structs are an example of taking those simple data types and creating a new data type, which is a struct that is composed of one to many of these other data types, with functions. And when a function is inside of a class, inside of object-oriented programming, they also get a new name. They are often referred to as methods. But methods, procedures, sub-procedures, generally speaking, they all refer to roughly the same thing. There are some nuances to them. But overall, it's not too big of a deal if you don't fully understand why one is called a method and one is called a function. They essentially are just blocks of reusable code. This way, the function and data all live very close to each other in the source code. Not sure about the actual machine instructions. At the time, I was thinking, well, in the source code, it's there. But when it gets compiled, the data and those blocks of functions are probably going to live elsewhere. I do believe that is the truth. Again, I've never looked that low level to see where they all actually live close to each other, relatively speaking. But if I'm understanding, my understanding is right, all of the data has a section where it lives, and the functions that we have also kind of just get placed somewhere else. They don't live together in the binary executable. In the source code, they're very conveniently together and they're all within the same class. So it does lead to some easy ways of working with stuff. But when you start getting into inheritance and polymorphism, they can start making things more complicated in virtual classes. Making source code easier to read. So this makes the source code easier to read and manage for the human. The last argument for objects, not to just be, oops, so this was me trying to, confirm what I'm saying to myself, was the last argument I had for objects not just being an object-oriented programming thing, an OOP concept, is how could a language become oriented towards objects if objects did not exist first? So that is kind of my argument I made to myself as to why I think this is the more correct way to think about them. And to think that OOP simply extends on what an object is and allows for more complex objects to be created. So we can have, like we said, we can have the data for the objects. We can have these large objects that have many data types associated with them, with many methods associated with them, and they can be virtual classes, and they can be classes that have complicated inheritance structures. And on a side note, a lot of the time when you're looking at YouTube programming content or even reading it, objects just get referred to as variables. So the little side note to myself was variables and constants are not necessarily objects on their own, but they are traits that can be assigned to objects. Variable meaning that the value of the object can change. I've written that wrong. It should say can change. And a constant meaning the value will always stay the same. But usually speaking, you never have to use the variable keyword in any programming language, because by default, most languages default to the object being variable, which is why in a lot of programming content, they get called variables. And this last section of my note was just me trying to, I guess, make a stronger argument for why the rest of the above is true, or why I prefer thinking about objects in this way rather than other ways. I do believe, like in the JavaScript programming language, I think they do have a concrete definition of an object which differs from this definition of it. I think they do refer to objects slightly different. I think there are examples out there where you can point to and say, well, this is wrong because they define it this way. This video was just kind of me going over, when I say the word object, what am I thinking about? And I really do think that thinking of objects in this way helped me a lot in understanding programming. So hopefully that made sense to anybody who might have watched this video this far through. And if you learned something, that's great. And I'll see you in the next one.